All right, guys, so for today's notes, we're covering the properties of real numbers. First, we have some definitions. Remember that you can pause if you need time to copy down. All right, so first is opposite. Opposite really means negative. So if you have a number A, the opposite is negative A. Remember, good note-taking strategy is you don't have to write everything down. For example, for this, I might write A, negative A. Okay, but for some of you, you might not know what that means if you were to go back later and look at it. So write down everything you need to if you need to, if it's going to be helpful for later, because that's what the notes are for. All right, so we have the additive inverse is called the opposite inverse. Interchangeable. And so that means that A is, well, not A is negative A, but A becomes negative A. Okay, so these two things are interchangeable. All right. Then we have reciprocal. So for A, the reciprocal is 1 over A. Okay, and the multiplicative inverse is just the same thing. It's for A, it's 1 over A. I don't know why those lines are so long. All right, now we have real numbers. Let me make my pen a little smaller so I can see better. So we use the symbol, the double-barred R, for real numbers. Okay, and this includes all numbers except irrational numbers. Rational numbers can be written as fractions, terminating decimals, or repeating decimals. Okay, some examples of those would be like 3.21, and a repeating decimal would be like 3.3 repeating. And then any fraction. If you can write a number as a fraction, then it is a rational number. An irrational number is no fractions. So if it can be written as a fraction, it's not irrational. Or non-terminating. Mr. Hayden, report to the library, please. Mr. Hayden to the library. Non-repeating decimals, sorry about that. So an example of that is pi, because pi is equal to or about 3.1415, and it keeps going and going. Right? Next we have integers. So integers are the natural numbers, their opposites, using that definition from before, and 0. So it'd be like -3, -2, -1, 0, 1, keep going up. We also have whole numbers, which are the natural numbers and 0, which would be 0, 1, 2, 3 on up. And then, of course, we have the natural numbers, which are counting numbers. It's the best way to describe them, because when we start counting, we start at 1 and go up from there. So it's going to be 1, 2, 3, all the way up to infinity. Okay? Then we want to talk about how they fit together. So, I guess I should have labeled these with different colors, but it's okay. Let's use red. So, I have a space of this right here, and this is going to be just all of our numbers right here. This is all numbers. Okay, there are two types of numbers. We have our real numbers and our irrational numbers. For those of you that had a hard time reading that, it's this. Okay, so within the real numbers, we have whole numbers. It's more exclusive of a group. So these are our rational numbers. Okay, then we have inside of that we have our integers, a little bit more exclusive. Then our whole numbers. And then inside of that we have our natural numbers. Okay, so they keep getting more and more exclusive the closer and tighter you go in. All right, so here we have some examples that we want to go over. It says, your school is sponsoring a charity race. Which set of numbers does not contain the number of people P who participate in the race? So I'm actually going to go over what answers don't make sense. Okay, so let's start from the bottom. We have irrational numbers. So irrational numbers include like 3.14, like pi, or square root of 2, or, you know, decimals that don't end, so 2.1, 2, 3, 4, 5, keep going up. Okay. Rational numbers are numbers like, it'd be like a fraction. So you could have a decimal like 2.1, you could have 3/4, etc. Integers is -3, -2, -1, 0, 1. So integers don't work because we can't have negative people. So no negative people. At least no negative amounts of people. So integers does not make sense. Rational numbers, we can't have partial people, and irrational numbers. Mr. Hagan, please report to the library with your computer. Mr. Hagan to the library. Okay, we can't have partial people either, so irrational and rational numbers does not make sense. Natural numbers are our counting numbers, so that makes sense. So A is our final answer for that one. Right, then it says, in problem 1, if each participant makes a donation of $15.50 to a local charity, which subset of real numbers best describes the amount of money raised? So we're trying to distinguish, just like in the one above here, which numbers would fit the amount of money raised. So let's think about it again. We want to think of the best one. natural numbers make sense because, we can't have negative amounts, but that does not include it doesn't include decimals. Integers, same thing, doesn't include decimals, whereas rational numbers does. If we were just taking donations for $5 and gave no change back, then it would make sense to do rational numbers, or I'm sorry, integers or natural numbers, but because we have the 50 cents, we have the fraction, then rational numbers is our answer. So rational numbers, because the amount might, keyword is might, contain decimals, which are terminating decimals. All right, finally, it's asking us, or not finally, but on this next part, it's asking us to graph these numbers, which are just different types. We have natural, integers, rational, irrational, and it wants us to put those in order. The easiest way to do this is to put it into a calculator, though you sometimes don't really have to do that. I think it's the easiest way. So 5 halves is a Jeez. Please report to the library with your computer. This is get to the library, please. So 5 halves, or negative 5 halves, is negative 2.5. Radical 2, off the top of my head, I don't know it. I don't have my calculator here. If you type that into a calculator, to square root, it's about 1.41, and it keeps going. And then 2.6 repeating is just 2.6 repeating. Okay, so you could kind of think about this more without using a calculator, and this is how I would do it. I would think, okay, well, I know the negative number is the smallest, so negative 5 halves comes first. Then I know that the square root of 2, well, 2 is smaller than 2.6 repeating, and then you're taking the square root of it, so it's even smaller than that. So radical 2 has to come next. And finally, 2.6 repeating because it's the last one we have left. All right, go ahead and number these ones or order these ones on your own. All right, this is just a note. The number line is helpful for ordering several real numbers. For two numbers, however, it is easier to show order or compare using one of the inequality symbols, which is this or this. So again, you can type these into your calculator or you can kind of think about it. The square root of 17 is between the square root of 9 and the square root of 16, which is 3 and 4. So I know it's somewhere between 3 and 4. That's not even correct. It would be somewhere between the square root of 16 and the square root of 25, but obviously closer to the square root of 16. Square root of 16 is 4, square root of 25 is 5, so it's probably going to be about 4.1. You can type in your calculator to figure out, but I feel confident with that answer. And it's not like it really matters anyway, because that's quite a bit bigger than 3.8. So we have the square root of 17 is greater than 3.8. Again, you can type it into your calculator, but if you can use that logic, it can really help you. All right, you're going to go ahead and do that problem on your own. All right, finally we have this last example, and this is just a little logic thinker. So if we have A, B, and C are real numbers, and A is bigger than B, A is less than B, and B is less than C, then how do they compare? So I'm going to create a number line. You might already know the answer off the top of your head, but it doesn't hurt to make a picture for those of us who are more visual. Okay, so A is less than B. I'm going to go ahead and write that down. A is less than B. So on a number line, we lead from left to right. So these are smaller and these are bigger. So A goes here and B is bigger. So it comes that way. It doesn't say what the numbers are. It just says they're bigger or less. Okay. Then our next thing is B is less than C. So then if I'm just looking at, I'm actually going to block this out for just a second. So if I'm just looking at B, then C has to be, then C has to be greater than this B right here. So I need to make this smaller again. So C goes right here on the number line. So then it asks, how do A and C compare? Now, it might seem obvious, but it's always good to draw a picture when you're confused or visual. A is going to be less than C. So that is how you would write your final answer. All right, that's the end of this video. Thanks for listening.